Chapter 10, Landslides and Slope Failure. In this chapter, we will learn about mass wasting and the human impact on mass wasting, the factors that influence slope failure, and the slope failure process. Natural disaster has become an increasingly anachronistic misnomer. In reality, human behavior transforms natural hazards into what would really be called unnatural disasters. Would you live here? Hill slopes make up most of Earth's land surface. These slopes fail when natural forces overcome the friction and strength of the underlying materials. Landslide is the common term used to describe the many forms of mass wasting. In February of 1998, after several years of above-average precipitation, the ground below Kelso, Washington began to move slowly downhill. The nation's first federal landslide disaster area. 137 homes were condemned, $70 million in damages. That would be $107 million in 2018 dollars. There were no deaths or injuries due to the very slow movement. Slope studies indicated the area was an inactive landslide of an unknown age. Areas where slope failures have occurred are more susceptible to slope failure in the future. City and developers knew this, but building permits were still approved and construction began in 1973. In Oso, Washington, in early 2014, Snohomish County, Washington, received 127 centimeters, which is about 50 inches, of rain, double the typical amount. A community along the Stillaguamish River near Oso was destroyed when a hill slope on the opposite side of the river collapsed. It carried 18 million tons of debris downslope. It was very fast moving. 43 people were killed and 49 structures were totally destroyed. It's the deadliest landslide at that point in time in U.S. history. Factors influencing slope failure. Slope angle. Gravity moves materials down a slope. Friction acts to prevent or slow the movement of material down a slope. Steeper slopes are more likely to fail. Think of a slide on a playground. The steeper and smoother the slide, the faster you go. Steep slopes in Sierra de Avila in Venezuela allow material to wash into narrow canyons that funnel debris toward coastal cities. The bare patches are the locations where landslides have occurred. There is an area on I-40 in North Carolina and Tennessee that it actually experiences frequent rock slides. And when it does happen, it usually closes parts of the interstate for days, weeks, sometimes only hours. Where do you see the areas of the highest risk for slope failure? And what do these areas have in common? There are two components of gravity that influences slope failure: parallel to the slope and perpendicular to the slope. The steeper the slope, the larger the component of gravity parallel to the slope, making it more likely the object will move downhill. Just makes sense. A small amount of water holds grains together, makes them a bit more sticky. Dry sand slopes will fail above angles of about 35 degrees. Too much water actually forces the grains apart. Too much water promotes instability. Very wet sediment flows like a liquid. Excess water reduces cohesion between grains and allows them to move more freely. It adds weight to a slope, and water supports some of the weight of overlying material, reducing perpendicular force on slope and reducing friction that counterbalances gravity. An example would be there's a higher risk for landslides in the Appalachian Mountains than in the western United States, where the slopes are steeper. Why? There's more precipitation in the eastern United States. The addition of water to the slopes with loose materials increases the likelihood of failure. Factors influencing slope failure. The Venezuelan landslides. This is the view from the Caribbean Sea. The mountains with the city of Carabalita in the foreground. And look at the steep slopes that feed right into where the city is located. A view up the canyon from Carabalita showing narrow canyon floor and steep sides. You can see that only the tall buildings are not under the debris in these photographs. 16 feet thick deposit on the canyon floor in Carabalita. Single-story buildings were buried. Apartments partially collapsed. Over 140,000 people became homeless. The burial of the main road impeded evacuation. Poor city planning, construction standards, building inspections all contributed. The cost of the damage was about $2 billion. Can we minimize slope failures? Here's a photograph of, this is one way that the DOT is attempting to keep the debris from falling onto the road. Improve slope drainage. Attach the slope material to the bedrock with physical restraints. This is the Beartooth Highway in Montana. There are 82 hairpin curves on this highway, and the slope failure is obvious. There are many places where the DOT has installed measures to attempt to keep the debris off the road. Slope failure processes. Landslides. Up at the top, what kind of landslide would you call this? Rockfall. Rocks falling when dislodged from a cliff or steep slopes as a result of physical weathering. A rock slide is the rapid movement of a mass of rock downslope along a plane of weakness. A slump is represented here. That's the downward rotational movement of rocks of unconsolidated material along curved surfaces. Creep. The very slow movement of unconsolidated material downslope under the influence of gravity. Rock slides are large-scale movements of rock traveling rapidly down a slope along a surface. The water softens the shale below the saturated sandstone, and then it slides along the wet shale layer, which acts as a lubricant. A slump is the movement of material down a slope of a curved slip surface. The debris flow. The material flowing downhill is a chaotic mixture of soil, rock, and water. I'm not sure I'd really want to live below a slope such as this. Looks like there's a